by using these given values, we can easily calculate delta L is equal to PL upon E. Okay, P we have to put in Newton, so 30 into 10 raised to 3. Length is given in meter, it should be converted into, follow, it should be converted into millimeters, so 4000. Area B into T, it is rectangular section. Okay, so 30 into 20, that is 600. I am directly putting the value. E, value of E is given in Newton per millimeter square. We have to keep as it is, 22 into 10 raised to 5. Okay, this will give value of delta L, which is equal to 1 unit is millimeter. Okay, delta L obtained. Now to get the other two, we have to use concept of Poisson's ratio. What is Poisson's ratio? Poisson's ratio. We already seen that Poisson's ratio. What is the notation for Poisson's ratio? Mu is equal to lateral strain upon linear strain or longitudinal strain. What is the definition? Lateral strain upon linear strain. Now what is lateral strain? When a rod is pulled, let us say this rod, whenever it is pulled along the length axis, length increases, but other two dimensions, मतलब diameter होगा circular है तो diameter, उसका जो ब्रेड का thickness होगा तो वो dimensions क्या हो जाते हैं? Decrease हो जाते हैं. That is lateral strain. Strain is what? Change upon original.
Yes.
Strain की definition क्या है? Basic definition? Change upon original. अगर वो length के terms में है तो change in length upon original length. वैसे अगर वो ब्रेड का thickness के terms में है तो change in breadth upon original breadth या change in thickness upon original thickness. Have you understood?
Yes.
So I can write mu as, therefore mu is equal to, what is delta L? Now again that day those were present, अगर delta L increase होता है मतलब length अगर increase होती है तो other two dimensions decrease हो जाते हैं. Is it clear? That is the concept of lateral strain. If length increases, other two dimensions reduce, they decrease. Okay, that's why we attach minus sign with this mu, Poisson's ratio. Okay, and that's why we can write mu is equal to minus delta L. Small l मतलब lateral. Small l का क्या मतलब है? Lateral. And capital L का मतलब है? Linear upon linear. Is it clear? Now you know this value which is 0.3 equal to delta L, we don't know, that we have to calculate. So minus delta L upon, what is delta capital L?
1.
Delta capital L is 1, or change in length upon original length. Okay, now 1 is only delta L. We have to calculate delta. This is, please correct me here. What is this? This is epsilon L upon epsilon capital L. Epsilon L upon by hand only. Okay. I was saying strain, but while writing I wrote it delta. Okay. So again I repeat the concept of Poisson's ratio. It is ratio of longitudinal lateral strain upon longitudinal strain. Lateral strain मतलब lateral strain is delta बोलो lateral length को perpendicular. Lateral का मतलब क्या है? Length को perpendicular. Length को perpendicular कौन से दो dimensions है? ये length है. Length को perpendicular मतलब इसका breadth और thickness. Okay, that's why epsilon small l is delta b upon b. Original b. Delta b means change. Upon b means original width. Okay, or what is the other value? Delta t upon t. लेकिन जब लेंथ इंक्रीज होती है तो क्या होता है? ये दोनों रिड्यूस होते हैं. दैट्स व्हाई वी अटैच माइनस साइन with it. Have you understood the concept?
Yes, sir.
I hope you understood the concept here. If length increases, breadth and thickness reduce. Both of them reduce. That's why we write negative sign with them. So अगर आप epsilon L find out करते हैं तो original B and original T आपको पता है?
Yes.
Yes or no? Original B and original T, they are known. Okay? You can easily calculate change in B and change in T. But for that you need to calculate epsilon small l, मतलब lateral strain. How to calculate lateral strain? For that, using, I take this, using mu is equal to minus epsilon small l, that is lateral strain, upon epsilon capital L. What is value of mu? 0.3. Therefore, 0.3 is equal to minus epsilon small l upon epsilon capital L. 1 is change in length. 1 upon original length. This is how 1 divided by change in length upon original length. Is 4,000. 1 upon. Have you understood this? Have you understood epsilon capital L or not? I will calculate it separately. I will write here longitudinal strain. Longitudinal strain epsilon capital L is equal to change in length upon original length. अभी समझे? Longitudinal strain मतलब strain.
Yes.
जब हम कुछ भी नहीं बोलते तो we only say strain. Strain मतलब कौन सा strain? Longitudinal, along the length. And whenever we say other, that time we use term lateral. जब lateral में use नहीं करता इसका मतलब क्या हुआ?
Linear.
It is always linear or longitudinal. हाँ लेकिन नहीं.
Yes.
Okay, so longitudinal strain epsilon L is equal to delta L कितना है? Delta L we have already obtained 1 upon L. L मतलब क्या? Original length. How much? Millimeter, because that is in millimeter, so
Yes.
denominator should also be in millimeter upon 4,000. Tell me this value.
2.5.
Therefore, epsilon L is equal to 2.5 into minus 4. ये हो गया longitudinal strain. And from this now you get lateral strain. So by putting this value in this equation, therefore minus epsilon small l मतलब lateral strain is equal to, tell me, 2.5 into 10 raised to minus 4 into 0.3, 7.5 into ये हो गया कौन सा स्ट्रेन? ये कौन सा स्ट्रेन है? Lateral strain. ये कौन सा है? All of you repeat with me. This is longitudinal or linear.
Yes.
We calculated delta L first using P L upon E. Okay, P Newton, L millimeter, area millimeter square, 2 into 10 raised to 5 Newton per millimeter square. We get delta L as 1 millimeter. Okay. After this, we have to calculate epsilon L, that is longitudinal strain. So longitudinal strain is equal to delta L upon L. Okay. Delta L is 1 millimeter. L, that is original length, is 4,000 mm. Okay, this is equal to 4,000 millimeter. So 1 upon 4,000 you get value of longitudinal strain as 2.5 to 10 raised to minus 4. Okay. Now after this we can calculate this value. Let's just simplify it again. So mu, value of mu is 0.3 is equal to epsilon small l, that is lateral strain we have to calculate, upon longitudinal strain is 2.5 into 10 raised to minus 4. By calculation we get epsilon L is equal to 7.5 to 10 raised to minus 5. Okay. Now if I just use this value for calculation of delta B and delta T, how to use that? So I'm just using it again. So epsilon L minus epsilon L is equal to, there are two dimensions in lateral direction. Which are the two dimensions? One is delta B upon original B, and other one is delta T upon original T. Change in breadth upon original breadth, change in thickness upon original thickness. Okay, this value is 7.5 into 10 raised to minus 5 is equal to delta B we have to calculate upon original breadth. How much it is? Original width is
30.
30 divided by 30. Therefore, delta B is equal to,
2.25.
but it is with minus sign, remember. There is minus sign here. Minus 2.25 into 10 raised to minus 3. Unit bolo? Millimeter. Unit is millimeter. What is significance of negative sign? Decreasing. Better you write down here. Significance of negative sign. Write down. Significance of negative sign is that if length increases, width and thickness decrease. Width and thickness, they both decrease. Okay, so to calculate delta T, how will you calculate delta T? You can use same definition of this, minus epsilon L, that is lateral strain, is equal to delta T upon T. Delta T upon T. Therefore, minus 7.5 into 10 raised to minus 5 is equal to delta T upon original thickness. How much? 20. Original thickness is 20. Therefore, delta T is equal to minus 10 raised to minus 3. Okay. So change in length is this much, 1 millimeter. Change in thickness, width is this much millimeter, and change in thickness is this much millimeter. Okay. Finally, you have to write these three answers.